Ubiquiti newly introduced the WAN SLA into its UniFi network application. Here on the screen, you see 4 different UniFi routers. On the top, you see UDM Pro and EFG. You can see both of them have the SLA as a available setting for your WAN parts, right? However, for the lower part, I'm showing you the UXG Pro and the old USG Pro. Neither of them has the SLA option. That's one observation, right? And then let me show you the router itself. So if I go to devices, go to UDM Pro, go to setting, I will leave screen there. Then let me show you other routers. Okay, for this comparison, the differences are even more significant. So see, for UDM Pro and EFG, I don't have anything related to the WAN SLA. However, for the UXG Pro, see here, I have the internet verification server and the DNS verification settings. And for the USG Pro, I only have the internet verification server, not the DNS verification. It's very messy here, right? So you may wonder what's going on. To explain that, we have to talk about Ubiquiti's history when it comes to WAN SLA support. You may see similar entries in your syslogs from time to time, such as high latency internet or packet loss for your internet. You may wonder where those messages come from, how the system detected the issues, how you can configure them. In fact, latency and packet loss, they are example metrics for WAN SLA. The only definition I can find from Ubiquiti about WAN SLA is here. It provides customizable monitoring of internet connection health to ensure reliable failover and maintain network stability. Different vendors have different implementations about WAN SLA, meaning they will have their own SLA metrics. When it comes to Ubiquiti, you can see even from this screenshot, the packet loss, latency, and the jitter are the 3 metrics included in UniFi's implementation. And for other vendors, you may see security or even application-specific metrics. Interestingly, for Ubiquiti, DNS is added as part of the WAN SLA, which is not very common to other vendors. We will see. For Ubiquiti routers, WAN SLA is not a new concept at all. For example, here you can see the legacy UI for a very old router, USG Pro. If I go to the setting under advanced, here you can see a thing called Echo Server. By default, it's using ping.ubnt.com. Even you don't touch it, the system behind the screen still running some processes to capture those metrics to guarantee the WAN SLA, even though there's no configuration labeled as WAN SLA. That's the very old version of network controller and a router. Then later, for example, this UXG Pro, Ubiquiti renamed the Echo Server to Internet Verification Server in its so-called new UI, but it's the same thing, and the domain name is slightly changed to ping.ui.com. A new setting is added, so-called DNS verification. But again, even you don't touch them, the system is still running something behind the screen. And in the most recent network application, the changes is Ubiquiti removed the internet verification server and the DNS verification out of the router's setting. Instead, it's moved to the internet setting. And Ubiquiti gave it a name called WAN SLA, exposed more settings so user can customize those metrics. Yes, slowly Ubiquiti has been improving the settings, but it's not a new thing at all, especially from the backend perspective. Nothing is changed. It's still the old way. In this video, we will dig deeper, understand how it's implemented behind the screen, how you can make sure it works First, let's take a look into the system to see how the system collects the metrics for the WAN part when all the settings are default. In the UniFi network controller, you can see in my lab environment, I use a UDM Pro, and for both WAN parts, I have the connection active, and the first WAN part is 10 gigabit port 10, and the second WAN part is port 9. And you can see I set it to failover only, which is the default. And then in the new SLA setting, you can see it's also default, which is auto. I didn't change anything, everything is default. In the left side, I have two Wiresharks. For the upper one, I'm going to capture the 10 gigabit part, the primary WAN part, which is active now. And the second, the lower Wireshark, will be capturing the port 9, which is not used backup second WAN part. So let me start capturing. By the way, in the capture filtering, I already configured it to only capture the ICMP and the DNS related packets. So you can see for both parts, they are busy. But I know at this moment, I do not have any real activities from the LAN part. What you see on the screen are the only clients I have. Apparently, they are not accessing internet, right? But you can see for both WAN parts, regardless whether it's primary or backup, it's very busy. For example, let me stop capturing. Then let me pick this IP address to understand what it is. Apparently, I am not running anything to ping this IP address, right? But then why on the WAN part, there's traffic about it. So in the lower part, in the Linux terminal, let me run dig command. Let me see whether it's from Google. Yes, it is from Google. You can see this 1, 2, 3, 4, 5, 6 pings. They are related to these 6 possible IP addresses for google.com. And then for other pings, for example, 111.8888, they are familiar, right? You know what they are. But the real question is why the system is pinging them. And then another thing I want to mention is, see here, for the DNS, I didn't do any DNS resolution operation, but the router is doing the DNS behind the screen, and see it tried 1111 and 8888, and each time it used the same domain name, which is ui.com. So for all this strange behavior, we didn't configure them. On the UniFi Web UI, you also don't see them. What the system is doing. Why so many busy packets? To understand that, we need to SSH into the UDM Pro. From the UniFi network controller internet setting, you can see now for both WAN parts, the SLA is set to auto. And from the IP addresses for the two WAN parts, you can tell they both have private IP addresses. The reason is, as shown in the diagram, my lab UDM Pro is behind my home main gateway. Both parts are connected to the LAN of my home network. They will get private IP addresses, right? But it doesn't matter to this video because they work the same way when they are public IP addresses. Okay, let me SSH into the lab UDM Pro. Let me show the current active IP addresses. You can see Ethernet 9 is for the primary WAN part, port 10, and it has this .2.100 IP address, and Ethernet 8, which is corresponding to the port 9. The backup WAN part has the IP address .15.98. Exactly as shown on the UniFi Web UI. Then, as I know, everything you configured in the UniFi Web UI, it's represented in this folder under Data, UD API config. So if I show all the files, you can see there are multiple files with different internal IDs. They are for historical changes, and this is the link to the current one. So let me show you this file. So there are a lot of configurations about network, but what I am interested is about failover. So let me search for one failover. Okay, found it. The first section of this one failover is about the interfaces, about the primary and the secondary WAN parts. So the first one, of course, is the primary WAN part, Ethernet 9 or port 10, the blue one as shown on the web UI, right? This section, see, is called monitors. This section is the focus for our video. Under the monitors, there are multiple monitors defined to monitor the network latency, connectivity, jitter, or the metrics you are interested in about the one part. So then for each monitor, see, there is a ID. Accordingly, I mark them in the diagram just for easy reading later. This parameter interval 3, which means whatever this particular monitor ID 1 does, it will do it every 3 seconds. And then time period 60 seconds, which means to complete one cycle, it needs to last for 60 seconds. Then the target is ping.ui.com. So remember, in old version of Unified Network Controller, we can see the internet verification server, which has this as the server, right? But in the new Unified Network Controller, if you set the SLA to alter, you won't see that. But behind the screen, in the internal setting, it is still there. So this is the old internet verification server or echo server in even earlier Unified Network Controller. Okay, so then here this part is important because it's alert. Later you will see for some monitors, it has the alert section. For some, they don't. So this alert section will determine whether they are the SLA for the one or they are simply used as informational monitorings. Later you will know what I'm talking about. But for now, see, this is alert. It only has one value, loss threshold. See, the type is ICMP. So basically this means if the system ping this particular domain name for 60 seconds, ping once every 3 seconds, if 50% of the pings lost, this monitor will be considered as failure. Then the system will do some alerting action. So this is the monitor number 1, right? Okay, move on. Monitor number 2. So interval 10 seconds, lasts for 30 seconds. The target, Cloudflare, and then here you can see the type is DNS. So basically this is the DNS server. And see here, it is another alert, which means it's part of the default one SLA. Now for this particular monitor, it has two values, latency threshold and loss threshold. If the system try to resolve a domain name, what domain name is hard-coded, is using UI.com, the system will do the DNS resolution for 30 seconds. Every 10 seconds, it will do once against 1111, try to resolve this domain name. If for latency is exceeding 1500 millisecond or is completely lost, it will be considered as a failure. Then it will send out an alert to fail the one part. So this is the second monitor. Move on to the third monitor. So this one is another DNS. DNS is really important to Ubiquiti because by default, the system only has 3 default alerting monitors. 2 of them are about DNS. This time, the DNS server is 8888. So the only difference between the third and the second monitor is the DNS server. Then move on to the fourth one. See, the fourth one is very short. Why? Because it's not an alert. See what it does. It's a ICMP. It will ping this domain name. This is a super long period, which is 1 day. Every minute, the system will do the ping once. It will last for 1 day. By the way, you may be wondering what ping.ui.com is at all, right? So we can easily check it by using dig. In the left side Linux client, let me dig this domain name. Okay, so it has a CNAME pointing to ping2.ui.com. And then what's ping2.ui.com? It's simply one of the 2 IP addresses, Cloudflare and Google. That's it. Interestingly, Ubiquiti decides to use the 2 common public DNS servers as the echo server, and this echo server is so important to Ubiquiti so that it has to appear twice, once as a alerting monitor in the beginning, the ID1, and then as hidden informational monitor the ID4. What's the purpose of this particular monitor? To be honest, I don't know. You will see what I mean by I don't know. But for now, let's move on. ID5. This time is also a ping. And this time, the ping will last for 30 seconds only. And for every 10 seconds, the system will do a ping. And ping Microsoft.com. Why I see this one behaves differently than the previous 4? The reason is in UniFi Network Controller, if you go to the dashboard, see in this section for each one part, you have these 3 icons. First one, Microsoft, then Google, then Cloudflare. Go back to the monitors. The monitor ID file is corresponding to this particular information. This latency is the result of this monitor file, right? And then later you will see the corresponding monitors for Google and Cloudflare. However, I don't see monitor ID4 where the information is displayed. Then in the same way, let's quickly move on to monitor 6 and monitor 7. So they are very similar to the previous Microsoft one. The only difference is the target. And these 3, monitor 5, 6, and 7, they correspond to the left side about latency. And the difference between monitor 4, 5, 6, 7 and the previous 1, 2, 3 is 1, 2, 3 are alerts. They are part of one SLA. The monitor 4, 5, 6, 7, they are not alerts, meaning even they fail, the system will not take action. For example, fail over to the secondary one part. No, the system won't do that because they are not part of one SLA. So then go back to our internet setting. We have found 7 monitors behind the screen for Ethernet 9 part, the primary one part. But on the UI, the only thing you see here for the first one part, the SLA is alter. Alter means behind the screen, the system hard-coded the 7 monitors. And we are not done yet about the Ethernet 9 part. There are some other values. Metric 1, let's put it aside for now. Then here, see the routing table 201, what it means. Let me launch another SSH session. I will show you. Let me run IP route show table 201. Okay, see a single line routing table. What it says is the default route is you go by using the Ethernet 9 part, which is the part 10, the primary one part, and this is the gateway. What's this gateway? It is my home main gateway, the upstream internet gateway. For internet traffic, you need to use Ethernet 9 instead of Ethernet 8. Why? Go back to the UniFi Network Controller. See, one mode is failover. At this moment, the primary one part will serve all the internet activities. That's what this routing table really means. We are done with the part for the Ethernet 9 part. Then for Ethernet 8, if you continue looking, you can see this is the section for Ethernet 8. In the exact same way, it has 7 monitors, and 3 of them have alerts, and 4 of them, they are just informational. They work exactly the same way as the primary one part. Then at the end, you see here, it has another 3 values. For metric is 2, and the routing table 202. Let me show you the routing table 202. You see, it's almost the same as previous one. The only difference is this time, it will use the Ethernet 8 as the interface, and this is the upstream internet gateway, which is the gateway connected with the secondary one part. So what this routing table really means is if you fail over to the secondary one part, your internet traffic will go through Ethernet 8 and go through another gateway in my home network. Before ending this JSON file, let's continue looking to see these failover groups. So you can see there are 2 failover groups defined. And the first one, Ethernet 9. The second one, Ethernet 8. And for the first one, it corresponds to the metric 1. What's metric 1? Remember I mentioned previously when we defined the monitors for Ethernet 8. See, at the end, it has a metric 1, right? Then for Ethernet 8, it has metric 2, right? So the metric value is used in failover groups. For the first failover group, it will use the primary 1 part, and the metric, the SLA, and all the monitors, it will use the metric 1, which is defined earlier. The connection reset triggers. This section is important. It explains what those alerts we saw earlier in the monitor definitions, what role they will play during the failover process. When the interface will be reset on activation, which makes sense. On configuration changes, makes sense. The third one, on one health bad. So which means we defined 7 monitors in metric 1, right? And 3 of them are alerts. If the 3 alerts fail, the one health is bad. It will trigger the connection reset. If we reset the port 10's connection, what it means? It means it will fail over to port 9. If the connection fail over to port 9, why your traffic will go through the port 9 instead? Because, see earlier, when you define your port 9, the Ethernet 8 part, you have a different routing table, right? So now everything is linked together. All the different configurations behind the screen work together to make the failover happen and to make the detection of a failure possible. The magic is you don't need to care about all the details if you don't want to, because on the UI, basically you do not need to change anything. I'm going to try to understand how this ICMP and the DNS monitors, how they are implemented in backend. So of course, if you want to do all the validations manually, you can use ping or dig command, right? But from backend, all these monitors need to be scheduled, run very frequently, right? So I really want to understand how they work internally. But the challenge is by default, all the target servers are either 1111 or 8888. Normally, if you ping them or do DNS name resolution against them, it will be very fast. So it will be hard to find out what processes are running. So to make my investigation easier, let me create a SLA which doesn't make sense purposely so that I can investigate furtherly. In the UniFi network controller, both SLA are altered. So let me create a new SLA. Let me say helper SLA and let me say ping, but here the server address, let me provide this one. So this is a IP address I know it doesn't exist in my internal home network. This subnet is in the one part for this lab environment, right? So I will force the system use this non-existing IP address as the verification server so that they will run for a long time. Then I have a better chance to see what's going on. So that's the idea. Let me see whether it works. I don't want to change anything because it's just for testing purpose, right? So let me add it. Okay. So now we have a new SLA, but we need to assign it to the one parts. So let me assign both, then apply changes. See, both one parts are showing red. They are offline. It makes sense because the verification server doesn't exist, so the system thinks the internet is down, right? Now I'm ready to go to the backend to see what's going on. Let me see what processes are doing something against this verification IP address. Okay, I see 2 processes which are depinger. This is important. Let me continue run it for several times. I don't see anything related to DNS because in the SLA, I haven't specified the DNS verification server, right? I have 2 process IDs and the process name is depinger. In fact, this process is used to implement the ICMP monitor. We will talk about this in details later, but let's first find out which process created this particular depinger process. Let me copy this PID. Let me run this command. So what I'm saying is I want to list the process. The PID is the one for depinger, which I just copied. And I want to list 3 columns, PID, parent PID, and then the command. Let me run it. the parent PID is 1368. If I run netstat command again, try to find this 1368. This is the process which is behind the screen running all the monitors. So the process name, it seems to be cut off. So to find out the complete process name, let me run ps, then grep the PID 1368. Okay, the process name is UBIOS UD API server. Apparently, it's Ubiquiti's proprietary server. So what really happens is this particular process will create multiple deep pinger processes for the ICMP monitors, and then it will also take care of the DNS monitors. Now we achieve the goal to find out the backend process names. I need to change the SLA to a regular one because now both one part are showing red, right? So I already created a SLA just for testing purpose. Let me set both one parts to that custom SLA. Then let me manage SLAs to show you what's defined. We will explain this server condition later. At this particular moment, it's set to any, and then the server set it to my home gateway's IP address. It's not really internet IP address because this is my lab environment, and to use a internal gateway, it will be faster. It will save my real internet traffic. So that's the purpose behind this setting. And then for other settings, there's no particular reason. It's just for testing purpose. I also defined a second verification server. So this time it's DNS. It's the same upstream home network gateway. And what I'm saying is, okay, let's try to resolve the IP address for google.com. That's it. And if we go back to internet, you can see now both the one parts are back to green because now this SLA makes sense. But from backend in the SSH session, let me see what deep pinger process are running. Let me make the window wider so that we can see each command in one line. It's a busy deep pinger situation. You may wonder what's going on, why there are so many deep pinger, right? Let's try to understand what really happened. So in the slide, let me switch to next one, which corresponds to my current SLA setting. Let's go through all the deep pingers. In the end, you will understand every single of them makes sense. It's the result of the monitor setting. So let's say for the first one, the I means it will use this label, this string, to output the result. It's just for information purpose. And this -b is important. It will bind to this IP address. So what's this IP address? This IP address is the second one part IP address. And you can also get the similar information by the I parameter, which means interface, Ethernet 8, which is the part 9, right? That's my second one part. Here, this is just a mask value, which is used internally by Linux kernel. And then here it says 2 seconds. Remember for the first alert, see the SLA definition? For the first verification server, we said ping interval is 2 seconds. So this is where the 2 second end up with. And then the D1 means in the latency result, the decimal place will be 1. It's just for output purpose. Then the T 30 seconds, because in the definition, we said time period 30 seconds. And then the -U is a Unix socket. The Unified Network Controller application needs this deep pinger result to determine whether the internet is healthy or not. The system needs a mechanism to communicate with the deep pinger. How? Through Unix socket. These two parameters are a little bit confusing because the -D is for loss delay. It's the tolerate delay before declaring packet loss. This is exactly what we defined in the SLA for latency threshold, right? And then the next one, the -L, 2S, is for latency threshold. It means about 2 seconds is considered high latency. So internally, it has two values, loss delay and latency threshold. But on the UI, you only define a latency threshold. Okay, and then the -J is for jitter we say 200 millisecond. And then the -L 20 means the packet loss threshold, 20%. And then this -C is a script the depinger will run if there's status change, meaning the loss, latency, jitter threshold, any of the SLA targets, they meet the condition we defined, the system need to trigger failover, right? So it will run this command. In fact, if you go through all the depinger processes, there are only 2 lines with this -C parameter, and one for Ethernet 8, the other for Ethernet 9. Why is that? Because only these 2 depinger result will be considered as the alert, as the SLA metric, so that it may trigger a failover. As we explained, even though there are so many monitors, only a few of them are marked as alert. That's what this -C for. Okay, so only for the very first instance, we explained all the meanings. For remaining ones, we will be very fast just to understand why the system is even running them. So you may notice some of the depinger processes are about Ethernet 8, some of them are about Ethernet 9. As you saw previously, for both WAN parts, the system runs exactly the same monitors, right? So just to speed up our process, let's focus on one interface only. So let's look into Ethernet 9, the primary WAN part only. So let me run the exact same command, but only display the Ethernet 9 related processes. Okay, then in another SSH session, let me show you the updated JSON file for the network configuration. This is the updated configuration file. This is for Ethernet 9, or the monitors, right? So see, the first one is for monitor 1. It corresponds to this first monitor, right? Which is exactly what we customized on the UI for the first verification server. And then the second one is for monitor 6. Let's see what's monitor 6. Is to ping 1111. See, it will ping 1111. Then move on to the third one is for monitor 3. And see, monitor 3 is a non-SLA monitor. The system run it by default, by itself. We have no control of it. In the configuration file, the target is ping.ui.com. But previously, I already showed you what's behind this domain name. In fact, it's simply either 1111 or 8888. So because there are 2 possible IP addresses behind the same domain name, the system generates 2 depinger sessions. The first one is about 1111. The second one, 8888. See, interesting, right? That's how the system responds to the 2 possible IP address situation. Then move on to monitor file. You can see monitor file is even crazier. You have 6 monitor file related processes. Why? So see what's monitor file? It's google.com. So if I launch a separate terminal, let me simply dig google.com. See, I got 6 possible IP addresses. That's why internally the system generates 6 processes just for google.com, just for one monitor. Even though it's just one monitor, the system has 6 depinger process to implement it. Another one, monitor 4, see monitor 4 is for microsoft.com. So the system has only 1 process for it. You may wonder, hold on a second, it seems we are missing all the DNS monitors, right? Let's see here, the monitor 2 is about DNS, which is missing in this depinger, right? Yes, it's not here, because depinger only handles ping, ICMP. DNS, as indicated on the diagram, by the UD API server process. Okay, so before ending this part, let me talk about one more thing about this radio button setting. The label is server condition. So by default, it's all, but for the current situation, I set them as any. Let's see what's the difference between all and any. So what you see in the lower right terminal, this JSON file is for the any occurrence. If you scroll to the end of the monitor setting, you can see the monitor health threshold is 100. I will leave screen here, and then later we will compare it with the OR occurrence. Now, if I go to the Unified Network Controller and I change the server conditions to OR, apply changes, then in the left side terminal, let me show the most recent updated JSON file. So now you see the exact same part of the setting side by side. You can see after we changed the server conditions to OR, you see this monitor health threshold, the value is 1. If you compare to the right side, it was 100. So what it really means, OR means I have two verification servers defined, right? Only both of them failed, the system will consider a failover. That's why the threshold is 1. It's a small number. But when the setting is any, the monitor health threshold is 100. It's a big number, which means any of the verification servers is very important. Any of them fails, the system will consider failover. That's how simple it is. Okay, let's move on to the very last part of the video. The last part is very short. It's about in real world how you want to set the SLA. Unfortunately, there's no a single good answer. There's no way a single setting works for everybody. In fact, that's the reason why Ubiquiti provides the one SLA setting in the most recent network controller, so that you can customize it to make it work. Think about it. In the old days, the system didn't allow you to change anything. So you have to stick to what Ubiquiti specified, which was 1111 or 8888, and with the SLA targets, the numbers, all hard-coded, you had to live with them, right? Now Ubiquiti give you a UI so that you can customize it in a very flexible way. Only if the default Ubiquiti setting doesn't work for you, then you may want to consider to configure your own SLA based on your own unique situation. For example, for your internet ISP, the connection to 1111 and 888 are not very stable, especially during some special periods of a day due to some ISP operations. The connection to the general internet, especially to 1111 or 888, are impacted, then the system will give you annoying high latency or connectivity warnings, or even failover may happen, right? So if you want to avoid that, you can select your own verification server. For example, if you trust your ISP's Echo server or DNS resolver, you can use their servers. Or if you have other servers of your choice, you can change to them. But if it is your lab environment, it runs behind another gateway, you may want to simply set the verification server to your upstream gateway's IP address. Again, there's no single way that works for everybody. You have to create your own custom SLA settings. And another thing I want to mention is when you create a SLA, you need to specify a verification server, right? So some people may not like this SLA function at all, but Ubiquiti doesn't provide a way to disable it. People may think, okay, here let me provide a LAN IP address so that it's always successful. Then we never need to bother about the annoying messages due to the SLA, right? But it won't work. The reason is if you check all the ping sessions, you can see they always bind to the one part, which means if you cannot reach your LAN from the one part, this SLA is guaranteed to fail. Okay, so just want to mention that your LAN IP address won't work. What I can recommend is if you have doubt about the results given by Unified Network Controller, or you want to try to see how your verification server will work, you may want to manually run depinger from the SSH session of your gateway to see the results using your own eyes. So for example, let me run this example. So I'm going to use my primary WAN part, and I specified all the 20% packet loss, 200 millisecond jitter, and 1.5 second latency. I set all these settings, and at the end I say let me use 8888 as my verification server. So let me run it. So you will see the system will output the result in this 4 columns fashion. First column is what you give as the information. This first number column is for latency. The second number column is for standard deviation or jitter, and then the very last column is for loss. So because now I'm using 8888, so you can see the packet loss is 0%. You can see the jitter calculation and the aggregated latency value. So you can see how it works, and you will understand the system does not give you the latency warnings for fun. You really have internet issue at some particular time. Then let me run the same command, but this time use a purposely wrong IP address. As I mentioned, I don't have a computer with this IP address. So let me run it. See this time, see the result, see the packet loss keep increasing, and then once it's after 20%, you see the alert is already sent out. Why? Because in the parameter we say 20% is our tolerant upper limit, right? But you can see the packet loss keep increasing all the way till it's 100%. Okay, this is just example. So Deepinger is a very handy tool. Not only Ubiquiti can run it from backend, you can also run it on the console just to check some result. Okay, this is the end of the video. It's a long one. Thanks for watching.